Good afternoon, everyone, and thank you for your presence here. So today I'm going to introduce you about a framework that I have built on top of ArgoCD. And show of hands, how many of you use ArgoCD in production today? Oh, glad I have somebody here. Okay, so those who don't know about ArgoCD, ArgoCD is a continuous delivery tool. So we saw, if you were present in our earlier session, Ram presented about Cuttle, a way to test your Kubernetes development from your local. So ArgoCD is a Kubernetes orchestration platform. It's a cloud native computing foundation open source project. And so today we will see the functionalities of ArgoCD and so how we build intelligence to a naive tool that could manage your Kubernetes clusters. Okay, so what's it about? So today we are going to build a sophisticated drift detection platform on top of Kubernetes. So what is drift? So how many of you had a production issue where a developer accidentally executed a kubectl command in production or in an acceptance environment? Okay, no one. So thankfully, that's what drift is about. Say, for example, traditional solutions, for example, Spinnaker, today what you do, you build your container image, then you use Spinnaker to deploy your containers, then you don't see what happens after that, right? So what we are trying to do here is, we are here to introduce ArgoCD and its capabilities. And so the configuration drift is when it occurs. For example, you deploy a container to your servers, then what happens is a developer comes and changes your configuration. For example, he scales or increases the pods accidentally, and in the next deployment, and that is rolled back. So that's what ArgoCD prevents. So it uses GitHub as a source of truth, and it follows the GitOps principles. So whatever you have committed to your Git repository, that's where your application state is, right? So you don't have a drift between your infrastructure as code and what you have deployed. So if something changes, ArgoCD notifies us, and it tries to auto-remediate. Okay. So again, ArgoCD is again declarative and a GitOps continuously delivery tool for Kubernetes that follows the GitOps pattern. So GitOps pattern is nothing but, once again, I have to repeat it. So you have all your source code in GitHub or any sorts of Git repository, and your infrastructure code is in sync with your cluster, in your Kubernetes cluster. So these are the core concepts of ArgoCD. So it follows the GitOps pattern. It's declarative. So you declare what you want, and ArgoCD takes care of it. And continuous sync. So this is most important feature of ArgoCD, or a core component, because it continuously monitors your GitHub state as well as the application state, and continuously keeps both them in sync, right? So if you commit your changes, so immediately ArgoCD deploys them to the cluster, and if something accidentally changed in the cluster, for example, if there is a security patch by the infrastructure team or a developer accidentally scaled the replicas, then the ArgoCD cluster goes into out of sync, and it tries to notify you, and you can build additional intelligence and policies to recover the state. So that's about continuous sync and self-healing. Yeah, accidentally if something goes wrong in the Kubernetes cluster, it can restore the state of your application to what was in the GitHub before. So this is the ArgoCD workflow. So you have the desired state in your Git repository, and ArgoCD syncs that and maintains your Kubernetes cluster also. So what are the native capacities of ArgoCD? So it offers application management out of the box. So deploys applications from Git repositories in even for multi-cluster environments. And it has native support for Helm, Customize, and even YAML deployments or YAML manifest. Then drift detection. So if something goes wrong, if something is changed in the background, so you need to know what has actually changed. So ArgoCD provides a nice UI where you can see the visual diff and provides a real-time sync monitoring, like what happened actually and who changed it, a nice audit trail, and whether it is in out of sync or out not. So this is the basic auto-remediation policy that Argo offers. For example, you can set this in your manifest so that if it's the policy is automated, it can remove the resources which are not in Git. For example, if you added a security patch or something, it will automatically prune it. And self-healing, for example, if you delete a resource or scale down the number of pods or scaled up, so it will try to correct the manual changes. So this is automatic remediation, and it has a nice web UI, which I will show you shortly. So if ArgoCD is so good, where does it fall short, right? So why this extension even exists? So ArgoCD is very excellent at the basic GitOps workflows, but enterprises and bigger organizations need just more than that. So what are the limitations of ArgoCD? So in a short while, I'll explain you 3 different scenarios where the severity for all the drift is treated equally. So the policy engine, so it has one size fit all remediation approach. So right now there are improvements for it, but I will show you what they are. And the notifications are pretty basic, and it doesn't leave a proper audit trail. And the approval workflows are not so elegant right now. So this is a real-world enterprise challenge, for example. So here you see 3 different scenarios. One is to scale the deployment. The other one is patching a service and deleting a secret. So all 3 are different severity levels, and they need different workflows, right? But ArgoCD's response, it has the same auto-sync behavior for all, so which is not ideal. So what we came up with is a different solution, adding intelligence to the existing ArgoCD capabilities. So what we did was adding contextual awareness to the existing ArgoCDs, and we added some policy-driven remediation instead of plain auto-sync and auto-prune. And we incorporated approval workflows. For example, if something goes wrong and if there is a manual intervention needed, we could add custom workflows for that. For example, you can integrate it with ServiceNow, and complete audit trails for compliance, then emergency response. So if a change is prohibited at all, for example, if someone accidentally deletes a cluster or deletes a pod, then we have emergency response for that. And for this quick start on this demo, what we need is a Kubernetes cluster, kubectl configured, and Docker for building the images. So I have set up this demo in such a way that even if you go home after this, you'll be able to run this demo in your local. And maybe if you're still interested, you could implement it in your organization and in your teams. So before going into the demo, I'd like to introduce some 4 extensions which are important for this demo. So first is the custom health check extension. It detects the replica count drift. It monitors the service type changes and identifies the configuration inconsistencies. Next is the application set. So we have 3 different manifests. There is a low severity application, a medium severity application, and a high severity application. And we have resource hooks. So we have 4 different resource hooks. So one is the pre-sync analysis. So whenever there is a configuration drift, the pre-sync hook will run, and it analyzes the drift and the severity and its impact. Then sync execution. So this is where the actual execution happens, whether to keep the configuration in sync or not. And you can control the policies in this YAML. And the final ones are the post-sync audit. So this happens when you need an audit logger. For example, if you need a config change and you make it and you need an audit trail for that, and the post-sync hook takes care of it. and emergency response. So for example, if the configuration drift occurs and ArgoCD is unable to restore the state, then we need a emergency rollback mechanism, and we have a fail fast for that. That's our emergency hook, or the sync fail hook. And the final one is the custom controller. So this is the brain of the entire system. So this is custom code again. It's the CRD also. So orchestration brain. So it implements the policy-driven response, and it manages the severity-based workflows, and it triggers the notifications, and it coordinates the drift analysis, as you saw from the pre-sync hook. So now let's go and dive into the demo. So for this, we need a Kubernetes cluster. For that, I'm using Docker desktop. And as you can see, I have a running cluster in my local. So now let's go ahead and install ArgoCD into this cluster. So as you can see, I'm creating this particular setup as a namespace for ArgoCD, a config map for ArgoCD, and we have custom resource definitions for the applications and application set, and we have the related service account, RBAC, and the role bindings. And if you could see here, we have some 5 deployments here. So these are the core components of an ArgoCD system. So you have the application set controller, the deck server, the notifications controller, Redis for caching, a repo server. So this is where it coordinates with the Git repositories and keeps the application state in sync. And finally, the ArgoCD server. This is where you interact with the CLI and the web API. So now ArgoCD is installed. Let us just see the UI, how it looks. Yep. Okay, so this is the initial UI. So we don't have any applications deployed yet. So as part of this demo, we will be deploying 3 different applications, and we will be showing you how each application responds to the drift. Okay, so this is a simple UI. We don't have anything as of now. Okay, so now we build the demo. So what it does is it builds the resource hooks. For example, we saw earlier that we have 3 different resource hooks: the pre-sync hooks, post-sync, and the emergency response hooks. So all of these are built, and the main application controller is built here. So all our Docker images, they are simple Python scripts, right? So after that, we are deploying the application set containing 3 different severity levels: a low severity application, a medium severity application, a high severity application. And now let's go see the UI and see the applications. As you could see, there are like 3 different applications, and 2 of them are sync, and the final one, the medium application, is not in sync because I have set the policy accordingly. So by default, when ArgoCD starts and when you deploy an application to it, the default sync status, it will be in out of sync unless you explicitly say you want an automated sync, right? So this is a medium severity application, and we have set the policy in such a way that it needs approval for any change, right? So here it says out of sync, and so what you do, you either manually go click on sync, or you have a continuous delivery process that does it for you, right? So for the initial state, we will just synchronize and see what's happening, right? So if you monitor here, you saw a drift analysis pre-sync job that started immediately, and in the logs you saw that it's analyzing the drift with the medium severity, and it associates a risk score for it, and this is for a medium severity application, right? So this is the pre-sync hook that executed initially. For any hook to execute successfully, the previous sync should be successful. For the example, this is the pre-sync hook. It doesn't have a prior hook, so it tries to execute. So next, we have the audit logger as the post-sync hook. So after the execution has completed, there is an audit log created. So again, this is all custom Python script, and we can integrate with any external system that you have, right? And after the pre-sync hook is executed, that is when the actual magic happens. Your application is now deployed to the Kubernetes cluster, right? So this is all the basic functionality of ArgoCD, but let me explain what we are trying to build and how we add the intelligence. So now let's try to create a drift, meaning I'll try to modify the replica count in the low severity application. Right? Maybe 3 replicas. So we have scaled it. Low severity application, maybe the application is running in a dev environment and we want to scale it. And before going to the UI, I'll just show you what's happening with our controller. As you could see, the controller is continuously monitoring the applications, and if you see the last couple of logs, you could see the sync operation getting triggered for the low severity application, and it detects the drift and then successfully triggered the sync because you have set the policies, and since it's the low severity application, nothing needs to be done. But if you see above what we did earlier for medium severity application, it was waiting for the approval background, right, with the 24 hours timeout. What we did in the foreground was we did go manually click on the sync, and then only it synced, right? So now once again I will show you the UI. So not this one. This is all in sync. Okay, so this is where our application comes. So we scaled it to scale the replicas, and if you see the logs and if you go to the events, it initially starts from out of sync and then it tries to sync immediately, right? So here what it happens was you initially had an application state in Git, but you changed the application state via Kubernetes. Since it's a low configuration drift, you still allow it. And if you compile the manifest, you will be able to see what has actually changed. So here, this is the policy. We have like the parameters in the manifest. We have automated true and self-heal true. So whatever you change, I think as a minimum change, automatically sync them, right? And you have a nice log which happens here, and also you have the pre-sync hook. It analyzes the drift and gives it the score as 2 based on the low severity, and at the same time after the sync is executed, you have a log that creates an audit trail, right? And it also has a metric. Next, I will show you the high configuration drift, and let's try to delete a pod or delete a service. Okay, okay, we try to delete a service. Let's see what happened here in the application. So we try to delete this healthy app service, but it's still there. You wonder why? Because our application controller detected this as a high severity drift, and based on the policies, it did not allow you to delete the application. So the application has been rolled back to the previous state of the Git history, right? So if you see here, you could see the Git status. So the application has been rolled back to this particular state, even though if you have executed the Kubernetes commands, right? So these are the high level or the intelligent factors that I wanted to highlight with the ArgoCD and how we extended the functionalities. So all of this is a working demo, and if you are still interested, you can go ahead, and if you have time today, you can go and clone this repository and try setting it up in your local, and you have all the information present. So now I'll be taking questions if you have any. Yeah, so this is the link for the slides and link for the demo and everything. And if you're interested, you can clone the repository. And now if you have any questions, please let me know. Okay, thank you so much for your presence, and I hope this particular demo will help you with your Kubernetes clusters. Thank you so much.